everyone, welcome back to our Further Math Past Paper Walkthrough series. I'm Hayan and I will be your video host for today's session. Siddharth, our contributor, will explain to you all the things that you need to know while tackling the paper Summer 2023, Paper 11. So, are you ready? Let's get started.
Yeah, hi guys, we'll be solving the Pure Maths 1, May June 2023. So let's get started. So first question, let A equals 3011. Prove by mathematical induction that for all positive integers n, 2a to the power n is equal to this. The format for proof by mathematical induction is always the same. So we start with the base case. So we check for n is equal to 1. So if we put n is equal to 1 directly on the left hand side, it means do it directly without the formula. We have 2a to the power 1, which is just 2 times a, which is just 3011. So what we get here is 6022. And if we do it with the right hand side, what we get is 2a to the power 1 is equal to 2 times 3 to the power 1, 0, 3 to the power 1 minus 1, and 2. So this is equal to 6, 0, 3 minus 2, 2, 2. So the left hand side is equal to our right hand side. So it's true for n is equal to 1. Now what we'll do is we'll check for n is equal to k. And let's assume it's true for n is equal to k. So the statement we have to write this. Assume that for n is equal to k, 2a to the power k is equal to 2 times 3 to the power k, 0, 3 to the power k minus 1, 2. And now what we do is check for n is equal to k plus 1. So what we have to do here is essentially just take a and multiply it with the a to the power n which we got before, 2a to the power n which we already had. This one. That gives us 2a to the power n plus 1. So we'll check it using the direct method and using the formula. So if it's equal, that means that the formula is true for all positive integers. So for n is equal to k plus 1, 2a to the power n plus 1 is equal to a times 2a to the power n. So this is equal to 3011 times, actually this, when multiplying matrices, this goes on the right. So I'll write this here. So we have 2 times 3 to the power k. We were taking k. 2 times 3 to the power k. 3 to the power k minus 1, 0, 2 times a itself. So 3011. So this is just equal to, so if we do the matrix multiplication, we have 2 times 3 to the power k times 3 plus 0 times 1, which is just 0. And then we have, on this side, we have 2 times 3 to the power k times 0 plus 0 times 1, which is just 0 again. On this side, we have 3 to the power k minus 1 into 3 plus 2 into 1, which is 2. And then we have 3 to the power k minus 1 into 0 plus 2 into 1. So that's just 2. So here what we get is 2 times 3 to the power k plus 1, 0, 3 to the power k, uh, 3 into 3 to the power k is just 3 to the power k plus 1, minus 3 plus 2, 2. And minus 3 plus 2 just becomes minus 1. Yeah. So now what we notice is that this is what we get if we directly substitute k plus 1 into this formula, which is just 2 times 3 to the power k plus 1, 0, 3 to the power k plus 1 minus 1, and 2. So that means that it's true for n is equal to k plus 1 as well. So now I have to write a concluding statement. Since true for n is equal to 1, k and k plus 1, by the principle of mathematical induction, it holds true for all positive integers n. Just give me a second. Yeah. So that's 1a. Find in terms of n the inverse of a to the power n. So we have 2a to the power n is equal to 2 times 3 to the power n, 0, 3 to the power n minus 1, and 2. Yeah. So a to the power n is equal to, just divide every element by 2. So we get 3 to the power n, 0, 3 to the power n minus 1 by 2, and 1 here. So the inverse of a to the power n is just going to be equal to, so the inverse of any 2 by 2 matrix, for example, a, b, c, d, is going to be equal to 1 by AD minus BC into DA minus B minus C. So the inverse of this matrix is going to be 1 over AD minus BC, 3 to the power n into 1 minus 0 into that. Anything times 0 is just 0, so I'm not going to focus on that. Then we swap the A and D elements. So get 1, 3 to the power n, and multiply these elements by 0. So we have 0 and 1 minus 3 to the power n by 2. This is just equal to 1 by 3 to the power n into 1, 0, 1 minus 3 to the power n by 2, and 3 to the power n. Yeah. Okay, let's move to the next question. The cubic equation x cubed plus 4x squared plus 6x plus 1 has roots alpha, beta, gamma. Find the value of alpha squared plus beta squared plus gamma squared. Okay. So we know that we can write alpha square plus beta square plus gamma square as alpha plus beta plus gamma whole square minus 2 alpha beta beta gamma plus alpha gamma. So this is just equal to the minus b over a minus 2 into, and this is the sum of roots taken 2 at a time, which is just equal to c over a. So minus b over a is equal to minus 4, and c over a is equal to 6. So this is going to be equal to minus 4 square minus 2 times 6. So 16 minus 12, which is equal to 4. Yeah. Use standard results from the list of formulae to show that this big sum is equal to n into n squared plus a n plus b, where a and b are constants to be determined. Okay. So let's just expand this out. So we get alpha square plus r square plus 2 alpha r plus beta square plus r square plus 2 beta r plus gamma square plus r square plus 2 gamma r. So we can write this as alpha square plus beta square plus gamma square plus 2r into alpha plus beta plus gamma and plus 3r square. So really this is just equal to sum from r is equal to 1 to n of alpha square plus beta square plus gamma square plus 2r alpha plus beta plus gamma. Give me a little space. Plus 3r square. Yeah. Now in the previous part, we found that the value of alpha square plus beta square plus gamma square is 4. So this is going to be equal to 4 plus 2r into, and we already found alpha plus beta plus gamma as minus 4 into minus 4. So this is just minus 8r plus 3r square. So we can write this as the sum of, I won't be writing it every time, but just for now, sum of r plus, or constants can move outside of the summation. So this becomes minus 8 summation of r plus 3 summation of r square. Now from the standard list of formulae, we have the sum of r is equal to n into n. Oh, just give me a second. I can't write up there, unfortunately. So from the standard result of formula, we have sum of r is equal to n into n plus 1 by 2, where the sum is still n. And the sum till n of r square is equal to n into n plus 1 into 2n plus 1 by 6. So this is just going to be equal to 4n minus 8 into n plus 1 by 2 plus 3 into n, 3n into n plus 1 into 2n plus 1 divided by 6. Okay. So we have 4n, 8 and 2 cancels, we get 4n into n plus 1, 3 and 6 cancel, and we get n into n plus 1 into 2n plus 1 by 2. Yeah. So let's just factor this and get it in the form in which they asked us to get it. So we can factor out the n. So we have 4 minus 4 into n plus 1 plus n plus 1 into 2n plus 1 by 2. So we can write this as n into 4 minus 4n plus 4 of minus 4n minus 4 plus 2n squared plus 2n plus n plus 1. Okay. 2n plus n plus 1. divided by 2. Sorry, only the last bit is divided by 2. So this becomes this 4 and this minus 4 cancel, and we have n into minus 4n plus this cancels, so we have n square plus 3 by 2n plus 1 by 2. Okay, so 3 by 2 minus 4 we can write as minus 5 by 2. So we have n into n square minus 5 by 2n plus 1 by 2. So from this it becomes obvious that a is equal to minus 5 by 2 and b is equal to 1 by 2. So that's this part of the question complete. Let's move to the next one. Use the method of differences to find the summation from r is equal to 1 to n of 1 by kr plus 1 into kr minus k plus 1 in terms of n and k, where k is a positive constant. Okay, so for the method of differences, we need to split this into partial fractions. So let's do that. So 1 by kr plus 1 into kr minus k plus 1. So let's assume that we can write it in the form a by kr plus 1 plus b by kr minus k plus 1. So this is one simplifying, like moving the reverse direction, becomes a into kr minus k plus 1 plus b into kr plus 1 divided by kr plus 1 into kr minus k plus 1. So now multiplying both this one and this one by the denominator, we get 1 is equal to a into kr minus k plus 1 plus b into kr plus 1. Now since k is a con, so what you have to do now is try to basically eliminate one of the letters, either a or b. So let's try eliminating b by making the coefficient of b 0. So kr plus 1 is equal to 0. So r is equal to minus 1 by k. So if we substitute this r back in the equation, we get 1 is equal to a into k into minus 1 by k, which is just minus 1 minus k plus 1 plus b into 0. So that's just 0. So we have 1 is equal to minus 1 plus 1. So minus ka. So we have a is equal to minus 1 by k. Yeah. So now let's do the reverse. Let's try to eliminate a. So see, kr minus k plus 1 is equal to 0. So k into r minus 1 is equal to minus 1. R minus 1 is equal to minus 1 by k. R is equal to minus 1 by k plus 1, which is equal to, so this becomes k by k minus 1 by k. Okay, substituting this back, we have 1 is equal to 0a, 0 into a, plus b into k into, so let's k into k minus 1 by k plus 1. So this becomes b into k minus 1 plus 1. So it becomes obvious that b is equal to 1 by k. Okay. So now that we got this, we can substitute this back at the top equation. Okay. So we can write this as minus 1 by k into kr plus 1 plus 1 by k into kr minus k plus 1. And we can factor out the 1 by k and just see what happens when we add it all up. So we have 1 by k into let's see, 1 by k into k, 1 by kr minus k plus 1 minus 1 by kr plus 1. So let's add this all up. Let's take the summation from r is equal to 1 to n of this. So you have 1 by k to 1 by 1 by k is a constant, and we can bring it outside the summation. And what we get is, so let's substitute r is equal to 1 first. So we have 1 by k, just outside everything. And if we put r is equal to 1 first, we get k minus k plus 1, which is just 1, 1 by 1, minus 1 by k into 1 plus 1, it becomes k plus 1. And when r is equal to 2, it becomes 2k minus k plus 1. 2k minus k is just k plus 1 minus 1 by k into 2 plus 1, 2k plus 1. And similarly, if we keep on substituting all the way up till r is equal to n, so we get 1 by k into n minus 1 plus 1 minus 1 by kn plus 1. Now what we notice here is that this and this cancels, this and actually this term will cancel the for r is equal to 3, and it keeps on cancelling until we're left with 1 by k into 1 minus 1 by kn plus 1. So that's our final answer. 1 by k, so just, okay, I'll leave it like that. So deduce the value of the sum from 1 to infinity. So previously we got that the sum from r is equal to 1 to n of this is equal to 1 by k into 1 minus 1 by kn plus 1. So now we have to find out the sum till infinity. So let's distribute this. So we get 1 by k minus or we don't need to do that. So what we notice is that as n tends towards infinity, this denominator becomes infinity. So 1 divided by a infinite number is just 0. So this whole part tends to 0. So this just becomes 1 by k into 1 minus 0. So which is just 1 by k. Okay, well, I think so I repeated this question, so let's just skip it. Okay. Find also the sum from n to n square of that. Okay. So suppose we have 1, 2, 3, 4, 5, all the way up till n minus 1, then n plus 1, all the way up till n square. So they're asking us to find out the sum of these from n till n square. So what we notice is that that's actually equal to the sum from 1 till n square minus this sum, the sum from 1 till n minus 1. So this is going to be equal to the sum from r is equal to 1 to n square minus the sum from r is equal to 1 to n minus 1. So we know that the formula for the sum till n is 1. Keep forgetting I can't write at the top. So we know that the sum for 1 to n is equal to 1 by k into 1 minus 1 by kn plus 1. Yeah. So let's substitute first n square. So when we substitute n square, we get 1 by k into 1 minus 1 by k n square plus 1 minus, let's now substitute n minus 1. So we get 1 by k into 1 minus 1 by k into n minus 1 plus 1. Let's factor out the 1 by k. So this is equal to 1 by k into 1 minus 1 by kn square plus 1 minus 1 plus 1 by k into n minus 1 plus 1. So this 1 and this minus 1 cancel. We left it 1 by k into 1 by k into n minus 1 plus 1 minus 1 by kn square plus 1. Yeah, so that's the answer. The matrix M is given by M is equal to this A, B squared, C squared, A, where A, B, C are real constants and B is not equal to 0. Show that M does not represent a rotation about the origin. So the matrix for a rotation about the origin is equal to cos theta minus sin theta and sin theta cos theta, where theta is the degrees turned counterclockwise. So let's do a comparison. So A, B square, C square, A. Now what you'll notice is that one second. Yeah, what you'll notice is that since C is being squared and B is also squared, this will always be positive. These two will always be positive. Okay, and over here, one is definitely going to be the opposite sign of the other. So they both can't be positive. So that's one reason why, but we need to elaborate more. Because one possibility is that because there is actually one solution to the equation minus x is equal to x, which is x is equal to 0. So there is we can say that minus sine theta is equal to 0, but they haven't allowed that since b can't be equal to 0. Since b square would be equal to 0, in the case that it was equal to 0, b would be equal to 0. So we get that's not allowed. So that shows that m does not represent a rotation about the origin. Find the equations of the invariant lines through the origin of the transformation of the xy plane represented by m. Okay, so we have a, b square, c square, a. times xy is equal to capital X and capital Y. So since it's a linear line, a straight line, y we can just write as mx. And it passes through the origin, so c is equal to 0. So mx plus c is equal to 0. So we just write mx. And this one we can write capital X. So m capital X. So multiplying it throughout, so we have ax plus b square mx is equal to capital X, and c square x plus amx is equal to mx. Now let's substitute this value for x over here. So you have c square x plus amx is equal to m into ax plus b square mx. Let's cancel out all the x's. So you have c square plus am is equal to am plus b square m square. So am can be cancelled out. So c square is equal to uh, b square m square. So m square is equal to c square by b square. So okay, I'll just continue on the top here. M can be equal to plus minus root c square by b square, which is just plus minus of c by b. So now there are two possibilities for the equation y. Since y is equal to mx, so we have y is equal to c by bx and y is equal to minus c by bx. So those are the equations of the invariant lines. Okay. It is given that M represents the sequence of two transformations in the xy plane given by an enlargement given by an enlargement with the center as the origin of scale factor 5, followed by a shear with keeping the x-axis fixed with map to phi 1. So let's call this first transformation as A. So you should know this, but in a matrix A, B, C, D, this column represents where the I hat vector of the plane goes, and this column represents where the j hat vector goes. So what that means is, so over here they gave an enlargement center the origin. So on the xy plane, it's always made up of two basic vectors, I hat and j hat, which is 0, 1 and 1, 0 and 0, 1. 1, 0 and 0, 1. So if they say enlargement keeping with scale factor 0, that means that I is being stretched by 5 units, so it becomes 5, 0, and j is also being stretched by 5 units, so it becomes 0, 5. So since I has now gone to phi 0, this becomes the first column of our matrix, and since j has become 0, 5, that becomes the second column of our matrix, so 0, 5. So that's A. Now let's find out B. So they said that the transformation B was a shear, keeping the x-axis fixed with 0, 1 mapped to phi 1. Okay. Same as before. What this represents geometrically is that I hat stays the same, so it stays as 1, 0, while j hat, which was previously 0, 1, is now being sheared. Basically, it's being moved to here phi 1. So since the I hat vector has stayed the same, the first column will be 1, 0 only. And since j hat has moved to phi 1, this second column becomes phi 1. Now, let's multiply these two matrices and find M. m is equal to ba. The reason why we put a here is because the vector which is applied first, so they give this comes first, the enlargement, so it always comes on the right. So m is equal to ba. So m is equal to 1501 into 5005. So that's just equal to 5 times 1 plus 5 times 0, which is just 5. And then 1 times 0 plus 5 times 5, which is 25. And then 5 times 1 plus 0 times 5, which is 5 again. Oh, wait, 1 second. 5 times 0 plus 1 times 0, which is 0. Yeah, 5 times 0 plus 1 times 0. Okay. And 0 times 0 plus 1 times 5. So that's 5. So that's on matrix M. You should, by the way, you should all be familiar with matrix multiplication. So the triangle DEF in the XY plane is transformed by M onto the triangle PQR. So we already got M as 525, 525, 0, 5. So that's the matrix M. So the triangle DEF is transformed onto PQR. So given that the area of triangle DEF is 12 centimeters, find the area of the triangle PQR. So now here comes an important property of matrices, which is that the determinant actually determines the enlargement factor of the area. So the determinant is just equal to AD minus BC, which is 5 into 5. Yeah, okay. I got confused. AD minus BC. So minus 25 into 0. So that's just 0. So this is just equal to 25. So the determinant of M is equal to 25. So what this means is that any area before the transformation, if it has an area x, after the transformation it will have an area 25x. So they gave that the area of the triangle before is 12. So the area of the triangle after will be 12 into 25. It's just equal to 300. So that's the answer. Okay. Question 5. The curve C has polar equation r square is equal to 1 by theta square plus 1. Sketch C and state the polar coordinates of the point of C furthest from the pole. So we have, so this is the line theta is equal to 0, theta is equal to pi by 2, and theta is equal to pi. So you can just plot this graph. So we have r is equal to square root of 1 by theta square plus 1. So substitute all the values of theta ranging from theta is equal to 0 till theta is equal to pi. And what you get is a kind of graph which looks something like this. And it's obvious that at this point, at theta is equal to 0, we have r is equal to 1 by theta square plus 1, 0 square plus 1. So this is just equal to 1. This is actually the furthest point from the pole, which is equivalent to the Cartesian origin. So the polar coordinates of the point C furthest from the pole is 1, 0, where 1 is the radius and 0 is the angle. Don't get it confused with the Cartesian coordinates. Okay. Find the area of the region enclosed by C, the initial line, and the half line. Theta is equal to pi. So basically, just find the area. This. So the integral of a the area of a polar curve is given by half integral of r squared d theta. So in this case, it's just half into integral from, what is it, 0 till pi of, what is r square? 1 by theta square plus 1 d theta. Okay, so checking the formula sheet, what we get is that this integral is just equal to, integral of 1 by x squared plus 1 dx is just equal to tan inverse of x. So this becomes half times tan inverse of theta from 0 till pi. So that's 1 by 2 times uh, tan inverse of pi minus tan inverse of 0. Tan inverse of 0 is just 0, so it's just half of tan inverse of pi, which the calculator gives us 0.631. So that's the answer. Show that at the point of C furthest from the initial line, this equation is true, and verify that this equation has a root between 1.1 and 1.2. Okay, so okay, so to find the point furthest from the initial line, we have to find it happens at the point dy by d theta is equal to 0. So we need to find the value of theta for which this equation is true. So dy by, so they gave that we have r square is equal to 1 by theta square plus 1. So we know that y is equal to r sine theta. So r is equal to y by sine theta. So let's substitute this. We get y square by sine square theta is equal to 1 by theta square plus 1. So y square is equal to sine square theta by theta square plus 1. And y is equal to sine theta by root of theta square plus 1. So that's what we have now. So let's find dy by d theta. So you should know how to derivate fractional functions. So dy by d theta is equal to, okay, write it here. So it's just equal to the denominator, which is root theta square plus 1, into the derivative of the numerator, which is cos theta, minus the numerator, sine theta, into the derivative of the denominator. So always a useful thing to have on hand is that the derivative of root x is equal to 1 by 2 root x. So the derivative of root theta square plus 1 is equal to 1 by 2 root theta square plus 1. Since theta again is contained in a function inside, we have to multiply by the derivative of the inside, which is 2 theta. This 2 cancels, and we are left with theta by root theta square plus 1. Okay. And this is all divided by the denominator square, which is the theta square plus 1. But that doesn't matter because we know that this has to be equal to 0. So when we multiply this just goes away. Okay. So what we have now is square root of theta square plus 1 into cos theta minus sine theta by root theta square plus 1 into theta is equal to 0. Okay. So now let's factor out a 1 by theta square plus 1. So 1 by square root of theta square plus 1. So what we're left with is theta square plus 1 here into cos theta minus sine theta into theta. So this just becomes 0. So just divide this on both sides and we just erase it basically. Delete it. And we have theta square plus 1 into cos theta minus sin theta into theta is equal to 0. So divide by theta everywhere and we get theta square divided by theta is just theta plus 1 by theta into cos theta minus sin theta. Theta divided by theta is equal to 1. And now if we just divide by sin theta, we are left with that. So dividing by sin theta, we get cot theta here minus 1. Also, this should be 0, not 1. I don't know why I wrote 1 there. Yeah, so we got this equation now. Okay, now verify that this equation has a root between 1.1 and 1.2. So the way to do that is basically check if there is a sign change. So for theta is equal to 1.1, theta plus 1 by theta of cot theta minus 1 is equal to, let's check that, 1.1 plus 1 by 1.1 into 1 by tan of 1.1. And this is something like also minus 1. Forgot the minus 1. So this is something like 0.022563 on and on. And for theta is equal to 1.2, if we just do the same thing, we get theta plus 1 by theta into cot theta minus 1 is equal to minus 0.209, something like this. So the idea is that, for example, look at this graph, okay? If at some value, for example, this x1, we have a negative sign, and for some value x2, the graph is positive, we know that since the graph has to connect these 2 points, there does exist some point at which it's equal to 0. So since one is positive and one is negative, we can infer that uh, there is a solution between these two, x1 and x2. So basically all we have to write is, since there is a sign change, since there is a sign change, there exists a solution between theta is equal to 1.1 and 1.2. So that's it. Let's move on to question 6 now. The curve C has equation y is equal to x square plus 2x minus 15 divided by x minus 2. Find the equations of the asymptotes of C. So obviously the one vertical asymptote is going to happen when x is equal to 2. But the other one happens since the degree of the power is 2 and the degree of the denominator is, the degree of the numerator is 2 and the degree of the denominator is 1, there is going to be an oblique asymptote, basically a slant asymptote. So to find that, we have to do long division. So x squared plus 2x minus 15 divided by x minus 2. So let's multiply by x, we get x squared minus 2x. Subtracting of 4x minus 15. So plus 4, we get 4x minus 8. So left with minus 7. So we can write x squared plus 2x minus 15 is equal to x minus 2 into x plus 4 minus 7. And now dividing by x minus 2 on both these sides. So this and this just cancel. I mean, it doesn't cancel directly. After splitting the fractions, they can cancel. But this right hand side basically just becomes x plus 4 minus 7 by x minus 2. So this thing, because the reason why is this thing is actually the oblique asymptote. The reason why being, as this tends to either minus infinity or infinity, the denominator becomes uh, basically zero. This whole thing becomes zero and negligible. So that's why the oblique asymptote is x plus 4. Show that C has no stationary points. So same thing, to find stationary points, we need to show that there exists some points x for which dy by dx is equal to 0. Let's find dy by dx. So dy by dx is equal to x minus 2 into derivative of the numerator, which is 2x plus 2, minus numerator into derivative of denominator, which is 2x, x squared plus 2x, x squared plus 2x minus 15 into 1 divided by x minus 2 squared, but that doesn't matter. Let's check if this equation has any solutions. Just bringing this to this side, we're left with x minus 2 into 2x plus 2 minus x squared plus 2x minus 15 is equal to 0. So we have 2x squared minus 4x plus 2x minus, what's going on? Let me just do this again. Okay, so we have 2x squared minus 4x plus 2x minus 4 minus x squared minus 2x plus 15 is equal to 0. So 2x squared minus x squared is x squared. Minus 4 plus 2 is minus 2x. Minus 2x minus 2x is... Okay, this just cancels. So we have minus 4x. And minus 4 plus 15, we have 11. Okay. Yeah. Now let's check the discriminant. B square minus 4ac. So this is equal to b square. So 16 minus 4 into 11. So this is going to be less than 0. Since it's less than 0, no real solutions, which means that there are no real values of x for which dy by dx is equal to 0. Okay. Sketch C, stating the coordinates of the intersections with the axes. Okay. So we know that there is one asymptote at x is equal to 2 and another one at x plus 4. So y is equal to x plus 4. So let's also just find the intersections. So x squared plus 2x minus 15 divided by x minus 2. Let's see, at when x is equal to 0, so let's find the y-intercept first. At x is equal to 0, we have minus 15 by minus 2. So that's 15 by 2, 7.5. So somewhere over here. And for the intercept, so let's see, so we have x squared plus 2x minus 15 divided by x minus 2 is equal to 0. So x squared plus 2x minus 15 is equal to 0. Let's find the solution for this. One, 2, minus 15. So you have minus 5 and 3. So just guessing from all these clues, we can draw the approximate shape of the graph. is something like this. Okay, I'll try drawing it again, but a little neatly. So we have one intersection here. So there's going to be one like this and one like this. This solution is 3. This one is 7.5. This one is -5. These are the intersections. So that's what the graph looks like. Sketch the curve with equation y is equal to absolute value of the whatever was there previously. Okay, so absolute value just means that whatever was there on the bottom gets reflected to the top. Yeah. So we have the same things from before. This x is equal to 2 part, and this y is equal to x plus 4, and this one also stays the same. But what happens is that before it was going down, now it gets reflected back onto the top. Oh, it's pretty terrible. Yeah. Similarly for this one, it gets reflected onto the top, like like this. Okay. Find the set of values for which this the y is equal to that is less than 15. So let's draw a point 15 somewhere over here. So this is the graph of y is equal to 15. This is the line y is equal to 15. Essentially, they're asking us for all the range for which this part is true. So it's clear that from this to here, it's less than 15. And from this part till this part also. It's basically just the intersections of y is equal to 15 with absolute value. So let's do. So 15 is equal to absolute value of 2x squared plus 4x minus 30 by x minus 2. Oh, by the way, this is multiplied by 2 on the top, but it doesn't matter. Something similar only. So 2x squared plus 4x minus 30 by x minus 2 is equal to either plus 15 or 2x squared plus 4x minus 30 by x minus 2 is equal to minus 15. So if we factor out the 2 from the top, we can just write this as x squared plus 2x minus 15 is equal to minus 15 by 2. And x squared plus 4x minus 15 by x minus 2 is equal to plus 15 by 2. Actually, this line is 15 by 2, not 15. Okay, so just quickly solving these equations, we have 2x squared plus 4x minus 30 is equal to minus 15x plus 30. Yeah. So 2x squared plus 19x minus 60 is equal to 0. That's one equation. And another one is going to be, in the case that it's equal to 15x minus 30, then we get 2x squared minus 11x is equal to 0. Yeah. So let's solve these two equations. Okay, so the first one is x square 2x square minus 11x is equal to 0. So x is 2x square is equal to 11x. X square is equal to 11x by 2. So we have either x is equal to 0 or we have x is equal to 11 by 2 if we divide it by x on both sides. So that's one range. And approximately on this graph, it would be here and 5 by 2. Where is it? Just give me a second. Yeah, this one. 5 by 2. Okay. Now let's find the reflected intersections, which would happen at 2x squared plus 19x minus 60 is equal to 0. So solving this, we get 19 minus 60. We get 5 by 2. X is equal to 2.5 and minus 12. So minus 12 would correspond to somewhere here, minus 12, 0, and 2.5 with this one. So it's clear that these are the ranges. It's also 11 by 2. Yeah. So it's clear that from these are the solutions from minus 12 to 0 and 2.5 to 11 by 12. So x has to be between minus 12 and 0, and x has to be between 2.5 and 11 by 2, 5.5. So those are the ranges of x. Yeah. So the final question. The plane pi 1 has equation r is equal to minus 4. Okay. So I'll write like this. There's no I hat. So that's 0, minus 4, minus 3, plus lambda into 1 minus 1, 1, plus mu into 1, 1 minus 1. Okay. So in order to obtain the Cartesian equation of the plane, what we need is two direction vectors on the plane, so we can find the normal vector, and one point on the plane. So two direction vectors we already have, that's this and this. So let's find the normal vector. So normal vector is equal to ijk of 1 minus 1, 1, 1, 1 minus 1. That's equal to, so take I and take the determinant of the remaining. So that's AD minus BC minus 1 into minus 1. 1 minus 1 into 1, that's 0. I. Now let's take J. So that's 1 into minus 1, which is minus 1 plus minus 1, I mean minus BC. AD. Once again, AD minus 1 minus BC. Oh, so this becomes 2 minus 2. And for K, we have 1, 1, AD 1 into 1 minus minus 1 into 1. So that becomes 2. Hold on. Something's going wrong with the signs. Always the signs. 1 into 1 minus 1 into 1. That becomes 2. Oh, okay. For the J, you have to put the minus sign. You have to reverse it, so it becomes plus 2. Yeah. So that's normal vector, which we can just simplify as 0, 1, 1. Okay. And now all we need is a point in the plane, which we have that 0, minus 4, minus 3. So let's write this equation as 0, 1, 1 into xyz is equal to 0, 1, 1 into 0, minus 4, minus 3. So 0 into x is 0, 1 into y is y, 1 into z is z. So that's equal to 0 into 0 is 0 plus 1 into minus 4 is the dot product, by the way. So 1 into minus 4, which is minus 4 plus minus 3. That's minus 7. So that's the Cartesian equation of the plane. The plane pi 2 has equation r dot minus 5, 3, 5 is equal to 4. Find the vector equation of the line of intersection of pi 1 and pi 2. So we can quickly write this in the Cartesian form, which is just becomes minus 5x plus 3y plus 5z is equal to 4. Find a vector equation of the line. So to find so imagine two planes are intersecting like this, and they create a line of intersection. So to find the direction of that line, all you need to do is take the cross product of the uh, two normal vectors. So the normal vector of this one, so we have I, j, k. So the normal vector of the previous one was 0, 1, 1. 0, 1, 1. And the normal vector of this is minus 5, 3, 5. Okay. So this is going to be equal to so that's 1 into 5 minus 1 into 3 j 0 into 5, so that's the minus 5 minus first 0 into 5 0 into 5 minus 1 into minus 5. For k we have 0 into 3 minus 1 into minus 5 again. So this just becomes 5 minus 3, which is 2, minus of 0, this becomes 0 plus 5, so it becomes minus 5 again. 0 minus, so this becomes 2 minus 5, 5. So that's the direction vector. And as for any point, we need just any point on this plane of on the line of intersection. So all we have to do is find a coordinate which satisfies both the equations. So first equation we had was y plus z is equal to minus 7. This one we have minus 5x plus 3y plus 5z is equal to 4. So to find any point, you can choose any point. So we can just take x is equal to 0, substitute x is equal to 0. So we have y plus z is equal to minus 7 and 3y plus 5z is equal to 4. After solving these equations, we are left with, if you have these type of calculators, you can solve it directly. So we're solving it directly. So 1, 1 into minus 7, 3, 5, and 4. So we have y is equal to minus 39 by 2, z is equal to 25 by 2, and obviously x is equal to 0. So that's one point. So one point on the plane, you can do it and verify that this coordinate satisfies both equations. So the position vector is 0, minus 39 by 2, 25 by 2. So now that we have the direction vector and position vector, all we need to do is just write it as L is equal to 0 minus 39 by 2 and 25 by 2. That's okay, just give me a second. So that's 0 minus 39 by 2, 25 by 2 plus t into the direction vector, which is 2 minus 5, 5. Yeah, so that's the solution. Okay, the line L passes through the point A with position vectors A minus 7. So A minus 7. And is parallel to 1 minus B. That's 1 minus B. Okay. Given that the perpendicular distance from A to pi 1 is root 2, find the value of A. So let's write down the equation of pi 1 again. It was y plus 7 is y plus z is equal to minus 7. So y plus z is equal to minus 7. So the equation for perpendicular distance is that ax plus by plus cz minus t divided by square root of a square plus b square plus c square, where x, y, z are the coordinates of the point. So we have a, which is the coefficient of x over here, it's 0. So that's 0 plus by, so that's 1. Okay. So that's 1 into the y coordinate, which is a, this one, plus 1 into the z coordinate also, which is a minus 7, and minus d. So minus d, which is this one, minus 7. So minus 7 becomes plus 7, divided by square root of a square plus b square plus c square, which is 0 square plus 1 square plus 1 square. So that's just 1 plus 1. Keep in mind this is all equal to root 2. So now solve this. We have a plus a minus 7 plus 7 divided by root 2 is equal to root 2. So 2a is equal to root 2 times root 2. 2a is equal to 2 and a is equal to 1. So that's it. And the second one, given that the obtuse angle between L and pi 1 is 3 pi by 4, find the exact value of B. Okay, so there's some plane pi 1 and the line L is passing through it. So they said that the obtuse angle is 3 pi by 4. So find the value of B. So L is parallel to 1 minus B. So that's the direction vector of L. So the direction vector of L is 1 minus B. And let's also find out the normal vector of this plane. Pi 1 is just, since it's y plus z is equal to minus 7, its normal vector will be 0, 1, 1. So now we can just use the formula cos theta is equal to n1, dot n2 divided by magnitude of n1 times magnitude of n2. So where cos theta, actually theta, you always have to take the acute angle. So since this 3 pi by 4, we'll take this angle as pi by 4. So cos of pi by 4, we get root 2 by 2. Let me just check. Yeah, root 2 by 2 is equal to n1 times n2. So we have 0, 1, 1 times 1 minus b divided by the magnitudes. So square root of 0, 1, 1 is just root 2, 1 square plus 1 square, into square root of 1 minus b whole square plus b square plus b square. So we have root 2 by 2 is equal to 0 into 1 by b is 0 plus b divided by root 2 into square root of 1 minus b square plus 2b square. So root 2 by 2 is equal to 2b by root 2 into this thing. Multiplying root 2 on both sides, we get 2 by 2, which just becomes 1 is equal to 2b by square root of 1 minus b whole square plus 2b square, and Square root of 1 minus b whole square plus 2b square is equal to 2b. Squaring both sides, we get 1 minus b whole square. I'll expand it. So we have 1 plus b square minus 2b plus 2b square is equal to 2b. Oh wow, it's getting longer than it needs to be. So we have 3b square uh, minus 4b plus 1 is equal to 0. Wait a second, something's gone wrong. Oh, this is 4b square. We squared both sides, remember? So it becomes 3b square minus 4b square. So that becomes minus b square minus 2b plus 1 is equal to 0. The solutions for this is b is equal to minus 1 plus minus root 2. Given that the obtuse angle, but they asked us to find the exact value of b. So it's given here only. A and b are positive constants. So that's why we have to take uh, b is equal to minus 1 plus root 2 only. So that's the only solution. So that's the last question.
Alright, thank you all for watching the video, and don't forget to subscribe to stay tuned for more episodes coming the way. Goodbye and see you again in the next episode.
Yeah.